Hello everyone, how are you all? I hope you all are fine and safe. Well, again, welcome back to Quantum Mathematics. I'm Aman, just welcoming you all to a new amazing video in which we are going to talk about the infinite product of cosine function. Like, we are just going to express this function as an infinite product, right? And yeah, this journey is going to be crazy, and this is going to be the shortest journey, I think, because we are just going to use some things. By the help of those things, we can just easily prove the infinite product, or we can compute the infinite product that represents cosine function, right? So basically we are just going to use the thing that we have used a lot of times in our past videos. And the thing is Euler's infinite product for sine function. Again, guys, I have used this a lot of times in my early videos, and even I have proved this thing with three different ways, right? And the most elegant one among all those three was in which I took almost no, it was an hour video in which I have proved this using the double angle formula itself. So that's really crazy, and you just have to check that out. It's the most recommended video for you guys, because you can, if whether you are a 10th grader or 12th grader student, you can understand that thing easily. So that is why I'm just requesting you to just watch that video once. Okay, so let's talk about this one here. So basically it is sine of z equals z times the product as n goes from 1 to infinity of 1 minus z squared over n squared times pi squared. So yeah, it's pretty fine, right? Okay, so this is what we have as the infinite product of a sine function, which was proved by Euler. Okay, so now, and the another thing is, we're just going to use the double angle formula, and even I have proved this in one of my early videos, so you can just consider watching. Even the things that we are going to use in this video, I have proved them with such simple steps by which you can prove that your own by just watching that. So these two things we are just going to use here actually. So basically let's just use them both. How are we going to use that here? So if we talk about the infinite product of sine function, so let's just replace z with 2z here. So it's gonna be sine of 2z equals 2z times the product as n goes from 1 to infinity of 1 minus its 2z whole squared over n squared pi squared. Okay, and now let's just do some changes here. It's sine of 2z equals 2z times the product as n goes from 1 to infinity of 1 minus, well, this can be written as 4z squared, right? So yeah, this is what we are having, n squared times pi squared. And let's just multiply with like I'm talking about, let's multiply like we can just take the common denominator here after multiplying here, n squared pi squared, right? So basically what we're talking about, let's multiply with n squared pi squared and divide with n squared pi squared. So that's gonna be here, it's n squared pi squared, right? And minus 4z squared over n squared pi squared. So this is what we are having, right? Yeah, it's fine. Okay, and okay, now I hope you understand that it's just basic mathematics, or basic like taking the denominator common. So that's it, right? Okay, so basically our final expression for this equation is sine of 2z equals the 2z times the product as n goes from 1 to infinity of n squared, I'm sorry, n squared pi squared minus 4z squared over n squared times pi squared, right? Okay, so this is what we are having so far, and let's just keep it in a box here, because this is one of those results. And again, the another result we need here is we are having this earlier actually. So this is what we are going to use. Actually, these two things are we are going to use here. So basically, you know what, from this equation we can say that, let me talk about here. So basically we have talked about sine of 2z as 2 times sine of z times cosine of z, right? So basically we're just going to divide both sides with 2 sine z. So we are gonna have sine of 2z over 2 sine z equals cosine of z. And if we are just going to replace this one and this one with some products like the way we did here, because that is why we evaluated sine of 2z in terms of an infinite product using the Euler's infinite product of sine function, so that we can just plug this product here over here. And again for this one we had the standard product, right? So let's just do that here. So basically what we are having so far is, well, cosine of z becomes the I'm sorry, we had a factor of 2z in front as well, times the product as n goes from 1 to infinity of n squared, I'm sorry, it's n squared pi squared minus 4z squared over n squared pi squared. And if we talk about 2 sine z, so it's 2 times this product, so it becomes 2 times z here. And well, you can write this one the way we did for sine 2z as well, that is, this is going to be n squared pi squared minus z squared over n squared pi squared. So let's just do that here with that also. So basically it is 2z times the product as n goes from 1 to infinity of n squared pi squared minus z squared over n squared pi squared. So now we're just getting a perfect cancellation here. The factors of 2z up front we had, and now we just got rid of those things. So basically we are having cosine of z equals the product. Well, since these two are things like which is getting from 1 to infinity, so we can just combine them, and we can just consider writing these two things as fractions of each other. Like what I'm talking about is, it's the product as n goes from 1 to infinity of the upper part is will be in the numerator as n squared pi squared minus 4z squared over n squared pi squared, and we had the denominator as n squared pi squared minus z squared over n squared pi squared. So n squared pi squared minus z squared over n squared pi squared, right? So basically we just got rid of these two factors as well, and we are having cosine of z equals the product as n goes from 1 to infinity of n squared pi squared minus 4z squared over it's n squared pi squared minus z squared. So isn't that amazing, guys? And yeah, it is really easy to prove this down using the double angle formula and the product that we have proved a lot of times, actually, like majorly 3 times. So whatever we have used in this video, we had a proof of these two things in my previous video, so you can just check that out, because we haven't used this out of nowhere. We have used this and we have proved these two things as well. And you know what the crazy part is, that we have proven this one using the Euler's formula, that was e to the I z equals cosine of z plus I sine z. So like look at the relation. So basically it is saying that, like, the relation of exponents with this double angle, what the hell is that? So it is, the both videos are must recommended. For the first one is for the infinite expansion or the infinite series for infinite product for this one, and the second one is the expansion of double angle, right? So yeah, it is must recommended for you guys, and it's pretty easy to prove this down. So well, it's not the shortest video because I have like explained you everything in detail, but indeed it was very easy to prove, right? So I think it's fine, guys, and yeah, just stay tuned for the next video, guys. And again, if you got to learn something from this video, just make sure to like, subscribe and share. And if you have any kind of doubt, so well, I have make sure that you don't get any kind of doubt. But still, if you got to any kind of doubt you have, so please you can just freely ask me in the comment section, even though I just write that statement down in my description box always. So you are free to do that, right? And yeah, just come up with the next I'll just come up with the next video, some crazy things like this one. And yeah, you know what, there's another representation of the cosine function as an infinite product, which is a standard one. So basically that's a standard one. So well, if you want, I can prove that down using this one only, or maybe we can add some other ways to prove that down. But for now, let's consider this one. And this is also correct, actually, obviously, because we didn't use any kind of things that is out of context, beyond the things that we have learned so far. Or yeah, it's pretty fine. But yeah, I'm just thinking to bring a new video on the another representation of the standard representation of the cosine function as an infinite product. So yeah, I think I should just begin working on that one also. So okay, goodbye guys, take care, love you. And just come back to the next video, because there are a lot of things waiting for you to be discovered by me for you. Goodbye guys, take care, love you.